I am Michael Barker from the University of Wyoming, and today we're going to talk about resiliency. We keep hearing that word come up in our industry, and it's becoming more and more important. And so for United for Infrastructure, the Short Span Steel Bridge Alliance thought we would put something together to help educate our engineers and students out there. But first, of course, I want to tell you about a little bit about the Short Span Steel Bridge Alliance. We're a group of bridge and buried soil structure industry leaders that have joined together to provide educational information on the design and construction of short span steel bridges. These are the types of people that are part of our alliance, and as you can see, it's all the stakeholders and government agencies and owners and even universities that are involved with the design and construction of short span steel bridges. What do we talk about when we talk about short span bridges? We're talking about buried steel bridges, like up there on the top left. Of course, the rolled beam and the plate girder bridges on the top right. We also have developed innovative systems like the press brake form tub girders on the bottom left there. And of course, the historical truss bridges that some of our manufacturers produce. And what do we do? Well, we do education. Like I'm the director of education. We do workshops and webinars. There's a Friday morning newsletter. This is an example of one of those. We have technical resources on standards and best practices and lots of case studies. We actually have developed a simple design tool where you can design a simple span steel bridge in just a matter of a couple minutes. And with that comes project assistance and question answering and that kind of thing. And then a lot of our members are bridge manufacturers that will produce and deliver a bridge for you. And of course, we do a lot of networking and meetings. So resiliency in our infrastructure is becoming more important. We all know about the bipartisan infrastructure law that went into place a couple years ago, where we're talking about a whole bunch of money going in to replace and rehabilitate lots of bridges. But that resiliency has become an important part of that, where there's actually an expectation of engineers and owners considering resilient operations, because we are looking to have more resilient infrastructure to natural hazards than we have in the past. And along with that, of course, we have the Federal Highway Administration that is pushing us forward in our resiliency of our infrastructure. One of the most important aspects of resiliency is service life and durability. How long will that bridge last? And you know, a long time ago, we used to want 50 years. Then it went to 75 years. Well, because of better materials and better design practice and detailing, we now expect bridges to last 100 years. So when we talk about resiliency, you got to start with what is a resilient bridge. And like I just said, service life and life cycle performance is the big one, right? How long will that bridge last? And within that, and in addition to that, we talk about robustness. Now, we've talked about robustness for decades. Now it's wrapped up into resiliency, where robustness is the behavior of that structure, or for us, a bridge, for unexpected demands, like when an earthquake hits or a natural disaster hits, or even a man-made disaster. Another part of resiliency is if it's out there and and we want to maintain it, it has to be inspectable and repairable if there is some damage. And of course, with increasing loads and with age, there are times where we want to rehabilitate and strengthen a bridge. And then, of course, sustainability is an important part of today's world, and we want our bridges to be sustainable. But given all that, because we could build a bridge that meets and exceeds every expectation, but it would cost way, way too much. So there is a compromise there. But the bridge still needs to be economical. So I thought we'd talk just a couple minutes on initial costs for steel and concrete bridges. Because in the beginning of the Short Span Steel Bridge Alliance back in 2007, that was our largest obstacle that we were trying to address, is that it was just assumed that concrete bridges were always less expensive than steel bridges in the short span market. And we knew that wasn't true. And so we've done case studies where we look at county bridges and state bridges, and we look at the actual costs and the bids from the request for proposals. And we have case studies on county bridges. We have case studies on state bridges. And these figures here just show you a couple examples of those. And after we did a bunch of those, NSBA, the National Steel Bridge Alliance, came in and did a national cost study based on different regions in the United States for all types of bridges. Here is some of their results for the short span bridges, where we're talking about, 100 foot or less is what this one is. And we see those costs down there where the steel plate girder and the steel rolled beam, and then a concrete I-beam and a concrete box beam and a concrete slab. And we see those, where there's the 25th percentile and the averages and the minimums and the maximums and all that kind of stuff. But what we see there is that they found the same thing we were finding, is that steel bridges are competitive in the short span market. In fact, one of the bigwigs, Mike from HDR did the study, said these conclusions come as a surprise to the authors, who just assumed, like a lot of people did across the country, that concrete bridges would be more cost competitive than steel bridges. And so that's kind of a first step. We need to consider both steel and concrete bridges for our bridge replacement needs. However, the smart owner wants to consider life cycle costs also, not just initial costs. And there really was not good information on that out there. The steel industry would say, oh, no, we've got better life cycle costs. The concrete industry would say, no, we got better life cycle costs. And so I conducted a study which did not use anecdotal evidence of predicting the future, but went backwards and looked at historical life cycle costs of steel and concrete girder bridges, where we looked at performance and maintenance and agency life cycle costs, or the true cost for a bridge for steel and typical steel and concrete bridges in Pennsylvania. And we certainly thank Pennsylvania for their database. And there are reports on our website, which I'll talk about a little bit later, that you can look at for those. Because I don't want to get way into this. I do want to show the bold part here. But the conclusions from these economy studies is that, yeah, typical concrete and typical steel bridges are competitive on initial cost, future costs, life cycle costs, and bridge life. And owners should consider both steel and concrete alternatives for individual bridge projects. And there's the website, which I'll show you again later, where you can find those reports. And in fact, we did an additional report or additional study on life cycle costs of galvanized bridges. So now back to resiliency. We said, hey, service life and life cycle performance, robustness, inspectability and repairability, rehabilitation and strengthening and sustainability. Now that we're going to consider both steel and concrete bridges, and I want to start talking about some of the advantages of steel bridges when it comes to resiliency. Well, that first one, service life and life cycle performance. There are thousands of steel bridges that are over 100 years old out there. Steel just has this reputation of being a long-lasting, well-performing, durable bridge. Why? Well, because of practical and effective design techniques, where we use the correct details to make sure water flows off it and that type of thing. And of course, steel is a very durable material. And of course, ductile. Inspection, everything's open to see, and maintenance and repair. We can use heat straightening. We can use replacement techniques. And of course, steel needs corrosion protection. We can either do that with steel chemistry, like a weathering steel bridge, or with the protective coatings like galvanizing, which Jeff is going to talk about in the second part of this one, or metallizing, which is similar, or even painting. So that second one was robustness for unexpected demands. And even in the early 80s, when I was in school, we talked about robustness. That steel bridge robustness is a bridge's ability to withstand damage and maintain its structural integrity, especially in the face of unexpected events or local failures. And we think seismic or natural disasters or man-made disasters. And steel is really good at this. We see that, of course, in the uh, uh, building industry with steel structures in seismic zones. But steel is very ductile, you know, it will deform significantly without fracturing or breaking. And of course, when we put a steel bridge together with multiple girders and cross frames and a attached deck, we have a very redundant system where if we do have an issue in one area, like damage or an overload, we have alternate load paths for that load redistribution. Then, of course, steel is lightweight for the strength you get, which reduces seismic forces. And then we have modern bolted and welded connections where over the years we've improved those so that they are resilient. Well, I just used circular reasoning there. I called it resilient. Where they're robust and they have ductility and deformation capabilities. And then, of course, ease of retrofitting. We can go in and repair a bridge or rehabilitate a steel member or even retrofit it. So this is a big one to me, inspectable and repairable, that when we go up to a steel bridge, we can see every part of that steel bridge. And that bridge may be damaged or deteriorated based on overloads or high or wide vehicle collisions, as we see in that top right picture where an overheight vehicle hit that thing. Well, with a steel bridge, you can come in and heat straighten that. Yes, it gets soft when you heat it, you put it back into place, but when it cools, it's back to that stiff steel. Structural vandalism or fire certainly can damage them, but again, fire hits, yes, it lowers our stiffness, it lowers our strength, but when it cools, as long as it doesn't get too hot, when it cools, it's back to steel. Fatigue, we can design for fatigue, of course, but if there is a fatigue issue out there, we can go out like that bottom left picture and arrest that crack. And corrosion, we can come back in and either replace parts of it, like that bottom right, or use some corrosion preventative techniques. Because steel bridges are accessible, it is exposed. You can look at everything. And of course, we have all sorts of non-destructive testing techniques that steel is very amenable to. And then if we have to repair, we can do modular repairs of sections, we can do fatigue management repairs, and we can do corrosion repairs because of the accessibility. So if we do have an older bridge that might have been damaged, or it's just old, or it was designed for an H-15 truck that needs to be upgraded, steel bridges are very susceptible to rehabilitation and strengthening. You know, on that top right, you know, the deck goes out on a truss bridge. Well, with a steel bridge, you can come in and get rid of that deck and place a new deck on there. Or maybe instead of that big, heavy 8-inch deck, maybe we can look at some other lighter weight decks like an orthotropic deck or a grid deck or a lightweight concrete deck to where we can increase the capacity of that bridge. We can prevent or mitigate corrosion and fatigue with coming in and painting or metallizing or that type of thing. And of course, seismic is a big modification of bridges, as you see on that bottom left. And if we just need to increase the strength of a composite or even a non-composite steel girder, that little picture right there kind of in the middle, we can simply put a cover plate on it. We can rehabilitate, we can strengthen a steel bridge rather easily. And then we come to our sustainability. Yes, it's a buzzword. Yes, it's important. And resilient or sustainability has kind of become part of resiliency, at least in my mind. And so I have a little picture here. On the left is resiliency. Yes, steel bridges are really good for repairability and redundancy and flexibility and adaptability and resistance to hazards and fast restoration. And on the right, for sustainability, we want to talk about recyclability and reduced material consumption and energy efficiency in construction, and of course, low environmental impact or CO2. and the intersection of these two is what we're shooting for: a resilient and sustainable steel bridge with 100+ year service life. And steel bridges have been doing that, and they will continue to do that. Now, if we look on the sustainability side, recyclability, well, steel is North America's #1 recycled material, more than everything else combined. That when you get a steel beam, it's like 90% recycled material. Reduce material consumption with the high strength to weight ratio. We can make that steel structure that is very predictable, very ductile, very resilient. We can make it an optimal weight while still maintaining that strength, durability, and safety. Energy efficient construction. Yes, it takes energy to make steel. It takes energy to make cement and concrete. But recycled steel conserves energy. And I just have this one thing, enough to power 18 million homes each year. And of course, steel's energy usage has decreased with the improvements in our furnaces and our processes. And it's been reduced 33% since 1990. All of these are important for the future. And of course, the big one that's always talked about is greenhouse gas emissions. And steel has reduced those 45% since 1975. And so I'm kind of heading into my summary here that I do believe there are some advantages for resiliency with steel bridges under strength and durability, that high strength to weight ratios, which allows steel bridges to resist structural damage. They're ductile, they're redundant, they're robust structures. And with the light weight, we can span great distances. A big one to me is ease of inspection and repair. That I used to inspect bridges. I used to go out there and look at them and rate them. And with a steel bridge, I can see what's there. Now, not very often, but sometimes there are some problems, right? With an older bridge, could be some corrosion problems, but we can see it. With an older bridge, there might even be a fatigue crack. We can see it, and we can inspect it, and we can repair it. Whereas some of the other materials, that's very difficult. Rehabilitation and strengthening for increased loads. We can quickly rehabilitate and strengthen a steel bridge, and we can do it while keeping that bridge in service with minimal traffic disruption. And of course, that long service life. There are thousands of 100-year-old bridges still in service. The innovative new systems that we talk about on our website and in some of our other educational programming have life expectancies well above 100 years. And I think Jeff Cunningham will talk about this a little bit. And of course, that's sustainability. That steel is a sustainable material, a recyclable material over and over again. And with that, I'm going to turn it over to Jeff. But before that, here's a little slide that gives you 5 ways to keep learning about steel bridges. I recommend you subscribe to the weekly newsletter. Dan Snyder, who is on the phone but is traveling, he's usually part of the question moderator. He's our director, as you can see there at the bottom. He sends out a Friday morning newsletter every week. I think it's at like 9:15 Eastern time. That tells you usually it's 3 different things that are happening within the short span steel bridge lines or within the steel bridge industry. You can find a supplier. If you need a 60-foot bridge, there's a place on there where you can call up some of those companies that will design, sign, and deliver you a bridge in just a matter, or so that you can just quickly put it in there and even use accelerated bridge construction. And then number 3, there's that design a bridge in a few minutes. That's at eSpan 140. Because now you can put a steel bridge design next to a concrete design and then let the market decide. Prior to this, you always had to start with a blank piece of paper and create a steel bridge design. And that was burdensome. And then, of course, you are certainly encouraged to contact us for project assistance or questions. Then that last one, schedule a workshop webinar. We do online certificate programs for the bridge industry. We're starting a new one this fall on the actual design of a simple span 80-foot plate girder bridge. We have other online things like this United for Infrastructure. But we also go and give workshops and webinars at many meetings and like at state, county engineering meetings and things like that. So I encourage you, go to that website. There's so much stuff there, so many case studies there. And if you have any questions, you can certainly contact Dan Snyder or myself. I've got my contact information on the website there also. And with that, Jeff, I will turn it over to you.
Awesome. All right. Well, thank you so much, Dr. Barker. Go ahead and share screen here. All right. Well, kind of piggybacking off of what Dr. Barker was talking about building a highly resilient, highly reliable, highly recyclable, sustainable bridge, that'll last 100 plus years. I did want to just kind of mention a couple of things. Everyone will get a PDF copy of this emailed to them. And anywhere you see one of these little mouse icons is a clickable link. So it's either to our project gallery, publication, white paper, resources for you guys. So just FYI on that. So I'm gonna go ahead and focus on hot dip galvanized steel, and we'll go over some of the properties that makes it highly reliable, resilient, and recyclable, and why it's a great building product. So first off, it's reliable. It is readily available. Galvanizers throughout North America. Is very cost effective and has accelerated construction schedules. Quick turnaround times. With hot dip galvanized steel, you can galvanize it and erect it within the same day. As soon as that piece of steel is cool enough to touch, it can be erected. It's highly resilient. Dr. Barker mentioned this. It does have a high strength to weight ratio of that to concrete, about 6 to 1, and it's highly adaptable as well. So there's future expansions, easily built upon, existing structures. Gives you design freedom as well. We're starting to see more AESS projects, architecturally exposed structural steel, using the steel as part of the architecture. And then, it kind of piggybacks off of what Dr. Barker said about being able to inspect it. The full structure of all the steel is visible and being able to easily inspect it, easily repair it, making it, reliable, resilient. And then it is highly recyclable. Like he said, is the steel is the most recycled material in the world, virtually, 99.9%. High reclamation rates for both iron and zinc as well. About 80% of zinc that is available to recycle is. So, and that number continues to grow every year. It's doubled since 2015, the amount of zinc being recycled, while zinc ore mining has remained almost constant. So it really makes hot dip galvanized steel a true cradle to cradle material. We talk about cradle to gate, start to finish, but as soon as that galvanized steel meets the end of life, it can be completely recycled without any loss of properties, and then put back into place and last another 100 or plus years. What is unique to galvanized steel from other different corrosion protective system is actually you get 3 levels of corrosion protection within one coating system. So the first one is going to be a barrier protection. The barrier protection resists corrosion by isolating the steel from the environment. It is a full immersion process. So that entire piece of steel gets coated with the zinc coating. It's fully immersed in the molten hot zinc bath. So you get, tubular structures, handrails inside and out. So it really resists the corrosion by isolating that steel from the environment. Then the second layer of protection is cathodic protection. And according to the galvanic series of metals, zinc is anodic to steel and will sacrifice itself to protect the underlying steel until all that zinc is consumed. So we know that zinc is going to sacrifice itself before the iron. So you have cathodic protection as well as barrier protection. And the last part is actually the zinc patina developing. This is critical for hot dip galvanizing long life. Zinc patina, like any other metal, develops corrosion byproducts like zinc hydroxide, zinc carbonate that build up on the surface and actually are semi-impermeable, which prevent overall corrosion rate or slows overall corrosion rate by preventing moisture and stuff like that. Zinc patina develops pretty quickly, anywhere from about a month up to a year, depending on the environment and how many wet and dry cycles it goes through. But that is critical in its long life. I like to show this as well because it is hot dip galvanized steel is extremely durable and abrasion resistant. This is a great cross section of a galvanized coating. It is different from other coatings like paint or even metallizing where it's a mechanical bond. The galvanized steel is actually a metallurgical bond and it's fused together when the zinc and iron react in the molten hot kettle. So you can see how the base steel at the bottom is 100% iron and it says 159 DPN. DPN is diamond pyramid number. It just stands for the hardness of a substance. So the higher the DPN, the harder the substance. Now, all the alloy layers, the gamma, delta, and zeta, are all a mixture of zinc and iron. So you can see that metallurgical bond happening. Gamma 75 zinc, 25 iron, delta 9010, and then zeta 94.6. But if you notice, all the DPN numbers of the alloy layers are going to be higher than that base steel. So it gives it that abrasion resistant. It's harder than the base steel. It's very hard to take off that coating. So once again, it gives you another layer of protection in one coating system. All right, so next section, I'm just going to highlight all of the AGA, American Galvanizers Association tools and resources for you guys. These are essential resources for designing hot dip galvanizing bridges. Once again, we give links on everything and as well. First and foremost is our website. Our website is absolutely a very, very powerful tool when you get to use it or when you get to know it and know where stuff is at. So we try to highlight everything at the very top for you. When you first show up, we have tools, resources right there, galvanizer locator, cost calculator, seminars, publication, everything real at the top. Our second bar down is going to be knowledge base and any kind of educational resources, that sort of thing. But our search bar is absolutely robust. And as soon as you start typing in stuff, it'll actually kind of come up with synonyms or show you related articles as well. So definitely something to take advantage of. Our website has a chock full of knowledge. All right, and on our website is the zinc coating life predictor. So this is the estimate of the corrosion rate of zinc in galvanized steel in various environments. You get to put in all of your, environments, curriculum, and statistical methods. It uses a neural network technology and extensive worldwide corrosion database. It's kind of nice because galvanized steel has been around for over 150 years. So we have an extensive worldwide corrosion database of galvanized steel. And it uses, it's developed from our time to first maintenance chart, but it's all customizable. So, you can put in exactly the parameters around your project. It was developed in conjunction with Dr. Gregory Zhang, who is famous for his overall corrosion data and scientific studies. So it goes directly off of the first time to first maintenance chart. And time to first maintenance is defined as 5% rusting of the steel surface. So still, very, very minimal. So when we go off of all the corrosion database for the last 150 years, we get the time to first maintenance chart, which is divided into five environmental subcategories. So rural, suburban, temperate marine, tropic marine, and industrial. As we know from ASTM standards, it requires at least 3.9 mils of zinc on any structural piece. From all galvanizers, it's going to be more like, 4, 5, 6 mils on a piece. But for sake of argument, we'll just say we have 4 mils of zinc on this piece, and we're building in an industrial environment, which is pretty corrosive. We're looking about 75 years before time to first maintenance. Now, we might get out at year 75 and notice that there is no rust or less than 5%. Or it might be at the end of its design life and ready to be recycled and rebuilt. So it just shows you off of real world data how long galvanized steel can last in some of the harshest environments. All right, these are another good ones to, when we're talking about buried structures, buried bridges. We have a bunch of soil charts on our website. We get this question from time to time, how well does galvanizing do in different types of soil? So we developed these charts once again off of real world data, and it uses moisture content, pH level, to define, or chloride content as well, to define which chart you're on. And anything in the gray or green is more favorable. Anything in the red is less favorable. So if we just take an example here, let's say we're working in low chlorides, high pH, we'd be on chart 3. And once again, around 4 mils of zinc is a good estimate. And we're still looking about 70 plus years in less favorable conditions. So once again, all available on our website. Definitely check it out if you have more questions. We have a full life cycle cost calculator. Now, this is the full life cycle cost savings throughout the life of the project. Total cost for initial, throughout, maintenance. This also includes time of value, so interest and inflation as well. Oftentimes you will see that hot tube galvanizing initial cost is its life cycle cost, just because we saw with the time to first maintenance, 75 years in some of the harshest climates, that you might not even see the 5% rusting. So initial cost is most of the time it's the life cycle cost. The life cycle cost calculator is to ASTM A1068. But it's super nice because you can put in all of your inputs and your reports, or all your inputs for your project, project parameters. You can compare it to different coating systems, epoxy, powder coat, all of that. And then it gives you a nice printout. You can even have it emailed to you in a PDF. Really good tool, really powerful tool. So if you ever want to, it's free to use. You can use it as many times as you want. If you go to our website, it's just lccc.galvanize.org. Once again, these are all links that will be sent out too. Every year we do the Excellence in Hot Tip Galvanizing Awards. This is a large database of hot tip galvanizing projects. There's over 2,000 hot tip galvanizing projects, and a ton of them are transportation and bridge and short span. So, you can look at real world case examples. Every project gallery submission has to include sector, year, location, environment, galvanizer, reason for galvanizing. We're even trying to encourage people to take thickness readings of their submissions, and then we're going to go back to those in 5, 10 years and take another reading to get kind of some more data points on the corrosion database. So if you guys are ever working on any hot tip galvanizing projects and think they're pretty cool, award worthy, definitely check out submitting them. We have different sections. Obviously, bridge and highway and transportation is a big one. But even all the way down to like OEM, we've had some tractors win. This tractor that folded out into a picnic table won a galvanizing award. So even small projects can win. So we highly encourage everybody to submit their projects. All right, inspection of galvanized steel. All steel is verified to conformance with ASTM specification. Usually just done with a visual inspection with the naked eye. Like Dr. Barker said, steel is easy to see if there's stuff wrong. Coating thickness is checked by a magnetic thickness gauge. And then we have a ton of resources for inspection of hot dip galvanized steel. We offer a free publication, free inspection course where you get a certificate and your name listed on our inspectors. And then we also have a, free inspection app. It's Google or Apple, and it's really nice because it doesn't require service to use the full app. So if you're on the, once you have it downloaded, you're on the job site in the boonies and don't have cell service, you can still use our full app. And it just gives a clear visual surface conditions of what's acceptable and not of galvanized steel. So if you're interested, definitely check out galvanizeit.org/mobile for more information. All right, a couple years ago, we launched our a new website in conjunction with our galvanizeit.org. It's markets.galvanizeit.org, and it's a website highlighting hot dip galvanizing projects and technical info, but it's organized by market and product type and state and provinces. It goes directly along the lines of the BIL, the bipartisan law infrastructure that just passed, and we're finally kind of seeing all the money trickle down to projects. What's really nice about it is obviously it highlights it by market, but then it will give you these animations, and each of these animations have anything in blue you can drill down into and see the components of that type of structure that can be galvanized. And more information on that, how to get it galvanized, where's galvanizer locator, all that stuff. But really cool, good information, a lot of BIL information. It drills it down by state as well, so you can go into your state and kind of see what's happening. Really cool, markets.galvanizeit.org. All right. We also have a ton of publications on our website, over 40 pubs available, all download for free. You can download multiple pubs. There's no limit on that. These are just a couple that I highlighted that were good for bridge and highway. Bridge specification publications. We have hot dip galvanizing steel bridges, a practical design guide. Reinforcing steel, we have a ton of rebar stuff. Duplex system, which is paint or powder coat over galvanized steel. Inspection of hot dip galvanized steel products, and then hot dip galvanizing for sustainable design, and it's just to name a few of them. We also have another sister website. It's galvanizedrebar.com. It's completely dedicated for just galvanized rebar. It goes over performance, mechanical properties, field handling, even gets into the nitty-gritty on design and bend diameters, that sort of thing. It has case studies, of course, publications, and then frequently asked questions. So if you ever have any questions about galvanizing, reinforcing steel, definitely check out galvanizedrebar.com. And then our knowledge base on our website is our frequently asked questions. We have more than 400 articles in Q&A form. They're organized by category. You can easily search it with our search bar. We have some of our frequently asked or our featured questions at the top. But honestly, about 90% of the questions we get have an answer in the Dr. Gaub knowledge base. So definitely check that out if you have a question. All right, some more bridge stuff, bridge specific tools and resources we have at the AGA. We definitely have a lot of bridge size considerations. We also have anything from short span all the way up to large. We, I'm sorry, we have a progressive dip calculator as well that I'll talk about in a little bit. But galvanizing, of course, is just limited by the size of the kettle. Now, the average kettle in North America is around 40 feet, although many of the newer ones are up to 50 or 60 feet. And we've been seeing either a couple things. You can progressive dip oversized pieces where you dip one side, you flip it over, you dip the other side. We've also been seeing more modular designs, so designing in modular subunits, kind of like the press brake tub girder systems, and then connect after galvanizing with either bolting or welding. And then we've also seen a combination as well with metallizing and hot dip galvanizing. And then, like I mentioned, progressive dip. The bridges of Stark County, and they were in pretty bad shape in the late 50s, 60s. And so throughout the 70s, it took about 10 years, but they decided to rehabilitate all of the bridges in Stark County. And there's a of 442 bridges, 335 were maintained by the county. So they went out, it took them 10 years, but they ended up stripping, regalvanizing a lot of them, and then using metallizing in conjunction with galvanizing. And honestly, they look good, almost 50 years later now. All right, this is the progressive dip. We actually have a bunch of resources, including a progressive dip calculator on our website that lets you put in your project parameters and make sure that it can be dipped. Um, but it honestly just depends on kettle dimension, part dimension, and material handling. So how the layout, what's lifting it, cranes, that sort of thing. Managing expectations, you will just, sometimes when people have a progressive dip on a big piece, there is a large overlap line. In appearance, maybe it might be darker, maybe a little rougher. You can kind of see it highlighted here in the bottom one. But that'll eventually even out. We have a couple of older bridges in our project gallery, like the Stearns Bayou Bridge. That was progressive dipped, and those lines have weathered out. Buffalo Creek Bridge, those lines have all weathered out. It's just uneven heating, and if you think about it, you're heating one side of the piece to 830 degrees Fahrenheit, and then while the other stays ambient, and then you flip it around and do it. So you might increase susceptible to warpage. Just you're introducing heat to one side and ambient temperature to the other side. You're going to release any residual stress within the steel. So you just want to have managed expectations. But if you have a chat with your galvanizer about progressive dipping or show them the piece you're interested in dipping, I guarantee they can fit it into their kettle or find somebody who can. Like I mentioned, here's some more resources for progressive dipping. We got that galvanizer locator on our website. It actually, you can sort by kettle size, so you can eliminate all the small kettles and stuff. Progressive dip charts. Once again, it's available through our progressive dip calculator as well. So lot of progressive dip stuff for you guys. Galvanizer locator. We have over 95% of capacity in North America covered. Approximately 70 companies, 170 different hot dip galvanizing plant locations. So chances are there's one by you. Search by address, state, company name. Once again, includes kettle sizes. And then it also includes any project gallery links. So a lot of the galvanizers will submit the projects they worked on, and then we'll put that in their galvanizer locator. So then you get a kind of a sense of what kind of projects they're working on and stuff like that. All right, so well, that kind of brings it back to the end here.